Double the cream, double the fun with new Oreo Double Stuff.
As you could see from the advertisement, Nabisco claims that their double stuffed Oreos really have double the cream and double the fun. Our question is, do double stuffed Oreos really have double the stuff? Hypothesis test and parameter. mu1 equals average weight of normal stuffed Oreos. mu2 equals average weight of double stuffed Oreos. The null hypothesis is 2 times mu1 equals mu2. The alternative hypothesis is 2 times mu1 does not equal mu2. Materials that are needed for this experiment are double stuffed Oreos, normal stuffed Oreos, balance, butter life. Method of data collection. Take 30 original stuffed Oreos from a pack. Place them on a piece of paper and label them from 1 to 30. Make sure to keep the Oreos in the same order as they were packaged. Use ren at 1 to 30 to select 5 numbers. Omit any repeats. This corresponds with the 5 Oreos that will be used for the experiment. Repeat the same process for the other 5 packages of original stuffed Oreos. Repeat the same process for the 6 packs of double stuffed Oreos. For the 12 package, we will select a total of 30 regular stuffed Oreos and 30 double stuffed Oreos. We are using 6 packs of double stuffed and 6 packs of single stuffed Oreos instead of 1 of each pack in order to reduce bias, variability, and confounding variables. If we were to use 1 pack of Oreo, the pack may have Oreos that have too much cream or too little cream than other packs, which might underrepresent the population. Also, we bought packs of Oreos from different stores so that they all in the same batch. Thus, tests and conditions. We are going to perform a 2-sample t-test because the test will determine whether or not the means of the 2 independent populations are different or we don't know the population standard deviation. In order to perform this test, we need to make sure that the conditions are met. The conditions are randomness. Oreos are randomly chosen from different packages of Oreos. 10% condition. Since this is a randomized experiment, there is no need to check the 10% condition in order to ensure independence. Normality. The sample size is 30, thus the experiment satisfied the central limit theorem. Procedure. In order to test our hypothesis, we are going to collect the data by weighting all the normal stuffed Oreos on the balance. Then we will remove the fillings from the normal stuffed Oreos. Make sure to remove all the fillings for more accurate data. After the fillings are removed, weigh all the Oreos again. The order in which these Oreos are weighted has to correspond to the previous order. Lastly, repeat this process for all the double stuffed Oreos.
These 2 tables are the data we collected from the experiment. The table on the left is the normal stuffed Oreos, and the table of the right is the double stuffed Oreos. Everything is in grams. The first column is the weight of the Oreos. The second column is the weight of the Oreo without the filling. The last column is the weight of the stuffings. These numbers are calculated by subtracting the mass of the Oreos without stuffings from the mass of the Oreos with stuffings. Graphs. Here are 2 graphs, a histogram and a box plot showing the data of the mass of the regular Oreo fillings. As shown on the graph, the range of the weight of the cream fillings ranges from 2.5 grams to 4 grams and centered around 3 grams, with the shape of the graph skewed to the right with 1 outlier. The minimum, Q1, medium, Q3, and maximum of this dataset is as follows: 2.37, 2.78, 2.975, 3.12, and 3.99 grams. The 5-number summary represents the sample percentiles. The sample minimum is the smallest observation. The lower quartile or first quartile represents the 25th percentile. The medium or the middle value represents the 50th percentile. And the upper quartile or third quartile represents the 75th percentile. And the maximum is the largest observation. Graphs. Here are 2 graphs, a histogram and a box plot showing the data of the mass of the double stuffed Oreo fillings. As shown on the graph, the range of the weight of the cream fillings ranges from 5.4 grams to 6.8 grams and centered around 6 to 6.2 grams, with a bimodal shape with 2 peaks around 5.9 and 6.5 grams. The minimum, Q1, medium, Q3, and maximum of this dataset is as follows: 5.55, 5.84, 6.225, 6.44, and 6.74 grams. Looking at the box plot, we can see that there is a larger range of values between the minimum and the medium as compared to the values ranging from the medium to the maximum. And it also shows that there are no outliers in this dataset. The possible explanation for the bimodal distribution of the graph is because 3 big packs of double stuffed Oreos were bought in one store, while another 3 packs were bought from a the other store. Meanwhile, there's a unimodal distribution for the regular Oreo fillings because multiple 6-packs were bought from several locations because they are more widely available.
Calculation.
The t-value is negative 1.14, the p-value is 0.25, and the degree of freedom is 43.14. P-value interpretation. Assuming that the true mean weight of the double stuffed Oreo cream filling is really twice that of the weight of the regular Oreo cream filling, there is a 0.258 probability of getting a difference in the cream filling mean in this study.
Conclusions, we obtain a p-value of approximately 0.258, which means, assuming that the true mean weight of the double stuffed Oreo cream filling is really twice that of the regular Oreo cream filling, there is a 0.258 probability of getting a difference in cream filling mean in this study. Since p-value equals 0.258, which is greater than the significance level of 0.05, we fail to reject whole the null hypothesis. There isn't convincing evidence that double stuffed Oreos don't have twice the amount of cream in the Oreos compared to the regular Oreos. Critical reflections, there are some sources of possible errors. For example, the cream might not have been entirely scraped off from the Oreos before we measured the weight. Also, we are limited by the tools we can have. All the scrapings were done manually with plastic knives. Some of the Oreo cookies cracked during the scraping process, which may cause some parts of the cookies to not be weighted during the measurement.
So now you know the results from our study. You can now eat your double stuffed Oreo cookies without the worry that you don't have the double stuffed filling you bought it for. Please enjoy your Oreos.